Good day. Well, I may have lied. I think I may need 2 more videos to take care of this. We're on to our next example. When we study organic chemistry, we're going to look into esters. And one of the fun things to do is esters can smell wonderful, like oranges, bananas, peppermint. But if things go wrong when you're making an ester, it can often smell like vomit. And of course, if you can do that, I have to give you extra marks. So we're given a sample, and we're told that it has this number of grams of carbon, this number of grams of hydrogen, and we'll have to do some subtracting to figure out the grams of oxygen. It does give us molar mass for molecular formula, so that tells us there's going to be a part D when we figure out the molecular formula of this ester. Alrighty, periodic table, our friend. So that's what we're trying to work out. Carbons, hydrogens, and oxygens. What are the subscripts? Well, the 511 grams was given, 42.55 moles carbon. 86.1 grams of hydrogen was given, 85.2 moles of hydrogen. We take these two numbers away from 825, and that will give us our oxygen. Well, we now have our moles of each beastie. And we can see that this is the smallest number. So we're going to divide everything by 14.24 moles of oxygen. That's what we're going to do on our next slide. So we're doing part C here. Okay, so we went through our moles of carbon, divided by, notice we're dividing by the moles of oxygen all the way through, 2.99, no problem, call that 3. 5.98, no problem, we call that 6. And of course this has to be 1. So we see it's going to be C3H6O. And that's going to be our answer for the empirical formula. And we say yahoodle. But now we have to get this right to have any chance of getting the next question right, where we're going for the molecular formulas from this information. So we know empirical formula C3H6O. So MF, molecular formula, it's going to be some multiple of the empirical formula. The 116.18 was given in the question. The 58.09 was calculated. 3 carbons, that's around 36. Each of those is 1, that takes us to 42. We add 16, that's the 58. And then the 3 and 6 give us the 0.09. You can see this question was nicely cooked, a little bit too perfect. Oh well. When we do division, we get 2, so we put a 2 outside our brackets. Now we blow out the brackets. And we have our molecular formula for our ester, C6H12O2. And if we're lucky, it might smell like vomit.